Hey guys, misfire and fuel trim. Oh, shoot boy. We're going to take fuel trim first, and then I'm going to split off misfire into like another presentation. Anyways, just follow along. Thank you everybody for helping me out on this. Long and short of fuel trim. We have, when we look at our scan tool, we have long-term and short-term fuel trims. And this means something. Short-term fuel trim, there it is, short-term fuel trim is on here, and it's showing 0, and then long-term is -1, so it goes into negative numbers. Now, short-term fuel trim is used by the PCM, and it's based off information from the O2 sensor. And it reads slightly rich and slightly lean. And we are going to talk about rich and lean, which is a terrible term. It's not very descriptive. Anyway, stay tuned. Short-term fuel trim reacts very quickly. This is to keep it centered into the O2 feedback into the closed loop. More on this later. Short-term fuel trim can only add or subtract a small amount of fuel. It's not very much. When we start talking about long-term fuel trim can add or subtract more fuel than short-term fuel trim. And what that means is it's in charge of a lot more fuel. Get it? The short-term fuel trim is a little tiny bit of fuel. Long-term fuel trim is a ton of fuel, or it can be. And look at that here coming up. And long-term fuel trim is slower to react. At least it should be. Although there are times where it will update very, very quickly, and we'll look at this when we talk about cells and some bit mapping stuff that's coming. All right, so diagnosis. I'm suggesting we ignore short-term fuel trim for right now. It's helpful, and there are some places where short-term fuel trim is very, very helpful, and we'll talk about that when we get in the lab, but not now. We're going to be looking at long-term fuel trim gives us more of a history. Now, remember before we talked about adaptive learning. The computers in vehicles nowadays are incredibly intelligent, and they learn how the car operates, and it looks for degradation and change, but it still needs to keep it in its fuel window, still needs to keep control of it for emissions and fuel economy. It still needs to adjust for this. So you think of it as we have a whole bunch of fuel that we can put in if the engine needs it. Let's say the injectors, as they age, they become a little clogged. They don't deliver as much fuel. Well, this is taken care of in long-term fuel trim. Computer sees it running lean for a while, and then it says, well, let's fatten up the mixture overall, So this is where the long-term fuel trim kicks up some. Now, long-term fuel trim can go into positive numbers or negative numbers, and we can see this on a good scan tool. And in fact, almost any scan tool will show you this. Now, I used to say this: if you add the two numbers together, you get the total amount of added or subtracted fuel. That's no longer the case. I don't see that as happening, in every platform. Some of the earlier platforms did that. If it was short-term and long-term had the same amount of fuel that each number was responsible for, but that's just not the case anymore. The long-term fuel trim can add or subtract a ton of fuel. Okay, we'll talk more about this. Anyways, map. Okay, so in the olden days, we used to look at this was called, I can't remember what it was called. I'll remember. It'll come to me. But anyways, in early GM land, we would refer to this, and 128 would be the middle. Lower numbers would mean that it's taking away fuel, and higher numbers than that. Block learn multiplier, BLM. That BLM, not the other BLM. That's block learn multiplier, BLM, not the other one that's been in the news. I can't talk about that. But anyways, so this block learn multiplier number was based on 128 was the middle. But, you know, in nowadays, when we start talking about, you know, fuel trims, I'd say, you know, ignore any numbers less than 10%. Okay, so if it's -8 or -6 or +6, I mean, heck, a brand new car I can get in and it's, you know, +2 or 3. I'm not overly concerned with that, but there are some caveats to this, and we'll talk about it. Anyways, so what happens? You know, let's say my long-term fuel trim is too high. It's a positive number. That means it's adding a bunch of fuel. That means it's responding to not enough fuel. Get it? So I don't have enough fuel, so it adds fuel to base. Whatever base calculations programmed in at the factory, it's adding more. Get it? So if it's too high, what am I looking for? Well, I'm looking for some place where I'm, you know, getting, you know, too much air. The air has changed, or for some reason I'm not delivering enough fuel, you know, like a weak fuel pump or something like that, or clogged injectors. I'm running more fuel, I'm holding the injectors open longer than I normally would. It's learned this behavior. This is specific to this particular vehicle. Sometimes you'll see, like if I have two O2 sensor, bank 1, sensor 1, 2 sensor 1, O2 sensors, I'll see them. I mean, they should be the same, but if one is different, then that's something that's affecting that bank. You get it? Anyways, we'll talk more when we get into class and start looking at these. All right, so let's say its long-term fuel trim is taking away a bunch of fuel. Well, this could be we're getting extra fuel for somewhere. Could be a leaky fuel pressure regulator, a leaky, dribbly injector, you know, something along those lines. It's getting too much fuel. You know, fuel pressure's too high, you know, something. Leaky fuel pressure regulator. Check for leaking injectors. Fuel trim examples. Okay, so here's an example. My long-term fuel trim is a +12. Is that high? It's high enough for me to think about. Especially the reason why it's in the bay is because something's wrong. Okay? Short-term fuel trim is just a +2. Well, that's a +14. Yeah, I'm looking at that going, well, you know, yeah, something's wrong. It's a little out of the tolerance I want to see. But how's the engine running now? Well, the engine's running now. It's running fine. It's only +2 in the short term. Get it? Now, long-term fuel trim tells me there's a problem, but short-term fuel trim should be bouncing back and forth. And that's what I want to see. You know, bouncing back and forth, O2 sensor. I'm going to put up a thing on O2 sensors and, you know, talk rich and mean at that point. Anyways, so here's the important little bits. We look at this chart right here, okay? And you see they're considered fuel trim cells. There's 16 of them, 15 plus 0, although some of them start out at 1 and go to 16. 16 is very common. Are there cars, different platforms with different numbers? Yeah. Are you allowed to see this on every platform? No, you're not. Although, sometimes you don't know what you're looking at. This is one of those numbers, a fuel trim number, that tells you something. Okay, but just know it's back there. That's the important part. This is how it works. Look, think of it as you know, across the bottom, it's RPM. And then on the vertical axis, it's load. So if I have no load and a slightly higher RPM than idle, I'm looking at cell 1 or cell 2 or cell 3. And then I start adding loads into this. It starts driving me up and across. Get it? This is where they keep those long-term fuel trim numbers. So I need to get the car where it's having the problem in order to look at the fuel trim numbers. You get it? If they're having a problem on the highway, or if they're having a problem starting out from stop, checking fuel trim numbers while it's sitting in the bay isn't helpful. I have to put it in to the cell that it's having the issue in. Or go check the cells, check the fuel trim numbers in these different cells. Take it out for a drive and look at my long-term numbers. I put it in a different cell. That long-term fuel trim number could pop. I mean, it should stay basically the same through all of these. Although, heavy acceleration, I see the numbers start to shoot up to 20. That means the computer is responding. Remember, this is an adaptive fuel trim. This is a learned response for this particular vehicle. Okay? What should it be? It should be 0 or pretty close to 0. 1, 2, 3, maybe varying a little bit. But let's say I stomp on it from, a start, and I see those numbers shoot to 20. That's an issue. Get it? Knowing which fuel trim you're in also has another thing. It's another thing. If we look at it, this is a statistically moving weighted average. And all that means, that's like math speak. For if we look at cells 4, 5, and 9, see those percentages in there? If we add those up, we come up to 100%. That's where it'll set the code for fuel trim. You get it? Look, some of these vehicles out there, a lot of them, we start getting into these other non-diagnostic weighted cells. Fuel trim could be way off in those cells and not show up as a code. Get it? This is something we got to go look for. How do we look for it? We go drive the car. Now, you could put it on a flight record, which is what I'm going to ask you guys to do in the lab today, is be able to flight record this and take it out for a drive. Okay? All right. Anyways, so they use these 16 cells for fuel trim corrections. So we look at the fuel trims, we need to look at the fuel trims where the problem is occurring. And then, if the car is having a problem under loaded highway speed, it's not going to show up as a fuel trim number that's useful sitting at idle in the bay. Got to take it for a drive. So here's another way we can use this. And so at long-term fuel trim and idle is plus 19. But, at 2,500 RPM, it drops back down to 0. This tells me something. It's dumping a bunch of fuel at idle, but no extra fuel at 2,500 RPM. Small vacuum leak. If I got a small vacuum leak, this is exactly how it looks like. So why is it not a problem at 2,500? Well, the percentage of air that's going into the engine, rather than being sucked in through this vacuum leak, is a lot less of a percentage, I think is the way it would be put. You get it? Anyways, all right, so here's another one. Long-term fuel trim at idle is plus 2. That's fine. Although long-term fuel trim at 2,700 RPM or 2,500 RPM is 27%. That's a bunch. It's dumping a bunch of fuel. Okay? So what does that tell me? Well, I'm thinking it might be a weak fuel pump. Could be something wrong with the injectors. Could be, a couple of injectors are starting to foul out and they're not dumping enough fuel. It's fine at idle, but we start loading this thing up and it starts to show in fuel trim. Now, sometimes you won't even notice this as being a problem. The only place you'll notice it being a problem is by looking at the scan tool. Get it? Anyways, misfire. All right, we're going to stop here. We good? Fuel trim is a great, thing to be able to look at. And I'm going to show you a whole bunch of stuff on this when we get out in the lab. Thanks, man.